Okay, so now we're into applications of quadratic equations. So we've got a problem, and this is a classic example of a quadratic solving. It says the height of a box is 3 inches, and the length is 3 inches more than the width. Find the width if the volume is 390. Well, they didn't put units, so let's just assume, oh, well, it's inches, right? So the volume would be 390 cubic inches. So I'm going to write that down in just a second, but let's write down what they've given us. And I've already drawn a picture of the box here. So let's write this down. We'll call h the height, and we're going to say that that is 3 inches. Okay? They say the length is 3 inches more than the width. Okay, so what am I missing here? Okay, the length is in terms of the width, so then let's call the width w, and it is just the width. And for now, we're going to give it a variable named w because we don't know. The next thing we know, the length L, okay, and what we know from the problem is that the length is 3 inches more than the width, so that makes it easy. W plus 3. So we've got our dimensions of our box. All right, let's call this right here going up the height, and we're going to label it with a 3. Okay, we're going to call this right here in the front the width. We're going to label it W. And then this right here running along the side, let's call this the length, and we're going to say it's W plus 3. So what do we know about volume? Well, of a rectangular prism, or even a cube, it's the length times the width times the height. Okay, so length times width times height. So let me write that down. The volume is the length times the width times the height. And in this case, the volume V is 390 cubic inches. So there it is. So now what we're going to do is we're going to come up with an equation. Okay, so what have we done so far in terms of the problem solving process? We read the problem, okay, then we made a sketch, all right, we assigned variable names, and our variable in this case is W, and it makes sense because it's the width. All right, now we're going to come up with an equation. Well, length times width times height should be 390. There's our equation. Okay, so let's take a look here. I have the length, which is W plus 3, times the width, which is W, times the height, which is 3, and that should equal 390. Okay, so there is my equation. Now let's try to combine some stuff. Okay, so this right here is going to give me 3W, and I'm going to have 3W times W plus 3, and it should still equal 390. Now we're going to do some simple distribution. 3W squared plus 9W equals 390. Now we've got a quadratic equation. Okay, so quadratics, you know, we're really obsessed with getting these guys equal to 0. So that's exactly what I'm going to do. So I'm going to take this and I'm going to come right up here, and I'm going to say 3W squared plus 9W minus 390 equals 0. So what did I do? I moved the 390 to the other side. Okay, so now we've got it. Well, guess what? This looks like something that I could factor, but before I even think about factoring, let's go ahead and factor out the greatest common factor, the GCF. What the GCF is in this case is 3. So here is my 3 that I'm going to factor out, and I've got W squared plus 3W minus 130. Set that equal to 0. Okay, so I factored it out. Now I need to factor this very simple quadratic. I need the factors of 130 with a difference of 3. Well, that shouldn't be too bad, okay? That shouldn't be too bad. Let's see. We've got negative 130. The factors, well, I'm thinking right off the bat 10 times 13. That's 130. And guess what? The difference is 3. So now we just need to figure out the signs of this. So how about negative 10 and positive 13? That right there will give me my difference of 3. So that's exactly what I need. Okay, so now let's write out the factors. So there's our 3 that we factored on the front, w minus 10 and w plus 13, and set it equal to 0. Now by the zero factor property, all I need to do is set each of these equal to 0, and I've solved for w. In this case, w equals positive 10, and in this case, w equals negative 13. Now let's stop and think about reasonableness of our answer. Could we have a negative width? You're right, the answer is no, we can't. So let's cross that out. Okay, so our width in this case will be 10. So we're on our way to finishing up this problem. If our width is 10, then our length is 10 plus 3, which is 13. So L equals 13 right there. And of course, we were already given our height H, which is 3. So these are the dimensions of this box. Okay, so it's got a width of 10, a length of 13, and a height of 3. So we've got that information down. The question said find the width. So here is really the answer that we were looking for. The width is 10 inches. Okay, so I can go back up here and say 10 inches. There's my answer. But of course, we always want to check our answer and just multiply the length times the width times the height. 13 times 10, 130, times 3 is 390 cubic inches. And guess what? It checks out with what we were given in the problem. So this is how we would find the width for this problem, this word problem.